This is AP Calculus AB, section 7.6, volumes of solids of revolution. This is pretty awesome. So let me give you the gist of it, and then we'll go through in the details. We are trying, and don't draw this, we are trying to take this shape that you see here, which is triangular. We're going to take this and we are going to rotate it about the x-axis. When we do that, we're going to end up with this shape that is essentially, if you can envision it, if we do this a bunch of times, we keep revolving this, it's like a Hershey's Kiss, where this is the top over here. What we're trying to figure out is, if we were to do that, if we were to take this curve that you see right here and revolve it around the x-axis at every point, revolve it around to make this solid, what would the volume of that be? That's what we're going to figure out. Finding volumes from revolving a curve around a line. And to think that we are capable of doing that is pretty awesome. Volumes of solids of revolution. We are going to focus today on the disk method. Next section, we will do the washer method. So big picture wise, without you understanding, to find the volume, you're going to take pi and then integrate from a to b of the radius squared with respect to x. Now, the reason that we're using this formula is that hopefully you remember that pi r squared is the area of a circle. So what we're doing here, now this is obviously an oval that I'm drawing. Maybe it's not so obvious. This is an oval that I'm drawing, but if this, from a different perspective, this oval would be a circle because we're looking at it from kind of like a 3/4 view. If you looked at this straight on, it would be a complete circle. And how do you find the area of a circle? It's pi r squared. We are going to be adding together a bunch of circles. Circle here, circle here, circle here, an infinite number of circles. That's why we have to integrate. So this represents this pi r squared, the area of one circle. When you integrate from a to b, we are finding the sum of all of these circles. This next formula is if you're revolving around the y-axis. If you're revolving around the y-axis, then this is your radius, and we're going to be integrating from something like maybe from 1 to 4. So these a and b values are y values. In this case, these are x values, and in these case, the upper and lower bound are y values. Let's get into how you would accomplish this. There's a bunch of steps, but it's actually not that complicated. Where big R of x and big R of y is the distance between the axis of revolution and the outside of the object. So like this example I keep coming back to. This distance here, R of x, it's just x squared. Because this curve, the y value at any place is x squared. So we would be saying, like for example, where x squared is the distance between the axis and the outside of the object. So step one, graph all boundaries. So what that might look like is graphing this curve and then graphing this. Find r squared. Well, in this case here, if r is x squared, we square that. R squared is going to be x to the fourth. If the x-axis of rotation, if the axis of rotation is the x-axis, then r of x is f of x. If the axis of rotation is not the x-axis, but some other vertical line, then r of x is the absolute value of the difference of f and a. essentially we're going to take the one on the right minus the one on the left. You don't have to worry about the absolute value if you do that. Or if we're going to rotate this around a vertical axis, we do this version, which is simply the same thing but with y's instead of x's. After you do step 2, find the upper bound and the lower bound from visual inspection of the graph. Like for example, this example coming back to the lower bound would be 0, the upper bound would be 2. And then you find the volume, and here's the formula once again. It's pi r squared, and we're integrating that. Pi is a coefficient, we can pull it out to the front. R, in most cases, is just the function, and we're squaring it. If you're revolving around a y-axis or vertical, then it's going to be this formula. Let's look at this problem in baby steps and see if we can make sense of this. Finding the volume of a solid of revolution. The steps, well, I guess they don't. Sketch the area bounded by the equation y equals x squared, y equals 0, and x equals 2. Well, that area would be this area in here. So yes, you should be drawing this at this point. So I'm supposed to do it for number 1. Number 2, revolve it around the x-axis to create a solid. So to revolve around the x-axis, we often draw this, which just shows what the axis of revolution is. So I'm going to try to draw this, and I'll try to draw it without using magical tools. I'm going to come down here to 4, come back up. If you looked at this at like kind of an angle, this is what we would see on the bottom. And then this curve is replicated down here like so. And it's this solid that you would see here. Not a great picture, but hopefully you can visualize that. 3, what does the area of a cross section look like? So a cross section would be like this blue part right here. What kind of a shape is this cross section? Well, it's going to be a circle every time. Which once again is why we're saying it's pi r squared. What's the area of a circle? Well, the area of a circle is pi times the radius squared. What is the radius of this circle? Well, this circle's radius, I'm going to get rid of some of this stuff so we can see it better, will be the distance here to here. Now keep in mind that this is going to change, because if we're trying to find the radius here, it's going to be smaller. It's constantly changing, oxymoron. It's changing by x squared. Well, its height is x squared, because at any given point, if you want to know what the y value is, you take the x value and you square it. 1 squared is 1, 2 squared is 4, which that would be here, 2 squared is 4, etc. So what is the radius of the circle? We're going to call that r squared, or we're going to call that r, I should say, which is x squared. What's the area of one of these cross sections? Well, it's pi times the radius squared pi r squared, so that's pi times x squared squared, which is pi x to the 4th. What's the volume of the solid then? And you know what, I regret doing this. We can just leave it like this in most cases. So the volume is going to be integrating from 0 to 2. 0 to 2 comes from the fact that this starts at 0, and then we're going here to 2. And then we have pi times the radius squared. And in most cases, I'm going to use brackets for this. That will probably be more obvious later. And in most cases, we're going to end up taking this pi and just putting it out in front. But it's fine to be in here as well. So that is a quick generic example of this. And let's flip to the second page. And let's do a real problem together without all those little steps. Find the volume of a solid formed by revolving the given boundaries about the given axis of rotation. So it says y equals x plus 1. That is clearly this. X equals 0. That would be here. I might have said x, that's y equals 0. X equals 0 is here. X equals 2 is this vertical line. Revolving around the y-axis, that's going to look like this. It can revolve in either direction. So what that's going to be, looks like this is intersecting here at 3. So let's say that's the same down here. When we're done with this, whoops, we're going to end up with both the top and the bottom of this are going to be circles. This overall shape was going to be kind of like a lampshade. Hopefully you can visualize it with my shading. I don't know. Step 1 is to put this stuff into the drawing, show the three-dimensional shape that it would be. Step 2, figure out what r squared is. Well, r is going to be the distance from the x-axis, that's where we're rotating it around, to this line. That's the line that's being rotated. This line is x plus 1. So r of x, this is step 2, is x plus 1. That makes r squared. If we square that, we're going to get x squared plus 2x plus 1. Step 3, find the upper and lower bounds, the domain, if you will. Well, this is starting at 0 because this was a boundary. These were our 4 boundaries, the red one, the green one, and the blue one. So it starts at 0 and it goes to 2. Step 4, find this volume. The volume formula is pi times the integral of x equals a to b of r squared with respect to x. For this specific problem, the lower bound was 0, upper bound was 2, and r squared is x squared plus 2x plus 1. The actual calculus of this, integrating this, it's super easy. It's no different than what we've done 100 times before. We just have a pi sticking out in front. So this is going to equal, we got this pi, we're going to have 1/3 x cubed plus x squared plus x, and we're evaluating it from 0 to 2. This is going to be pi times 1/3 2 cubed plus 2 squared plus 2. Subtracting from that, 1/3 times 0 cubed plus 0 squared plus 0. This also has a pi times it. This pi is times everything. So it's pi times all 3 of these and pi times all 3 of these. And I nearly left off one of my pi's here. Now this whole thing's going to end up being 0. Get 0 cubed times 1/3, 0 squared, and we got 0. So it's going to be pi. This over here is just going to be 0 times pi. We're going to have 2 cubed is 8 times 1/3 plus 4 plus 2. I'm just going to go ahead and make this all one fraction here. We're going to have 8/3 plus 12/3 plus 6/3. That's going to give us 26/3 pi. And we weren't given units, so we'll just say it's cubic units. It's real important that we understand this has to be cubic units because we're finding a volume. And that's it. That's not so bad. This next problem, we're supposed to use a calculator. It says we got y equals 3x squared. That would definitely be this part right here. We got y is 2. We got x is 1. X is 1. Well, I'll get to x is 1 in a second. We have x is 0. Now this x is 1, we don't really actually need because x being 1 means right here. And clearly we can see that these are intersecting here, so it's kind of redundant. We're revolving this around y equals 2. We're using quadrant 1 only, it says. So the shape that we're going to get here is going to be something like this. It's like a Hershey kiss here. I am mirroring this down here as best I can. So this is the shape that we're looking at. This 3D Hershey kiss-like shape. This says use a calculator, but even though we're using a calculator, we still got some work to do here. We got to figure out what r squared is. First of all, what is r? R is the radius. R is the distance from this green line to this y value. If we take high minus low, that means that we have 3 minus x squared minus 2. That's going to reduce 3 minus 2 is going to be 1. That's going to be negative x squared minus 1. That's what r is. Well, what's r squared going to be? If we square that, we're multiplying it by itself. We're going to end up with x to the fourth plus 2x squared. You know what? I got this wrong. This right here should be a plus 1. 3 minus 2 is a positive 1, which makes this minus 2x squared. It's going to make this a plus 1. If you need to see the work for squaring this, negative x squared plus 1 times negative x squared plus 1. This is going to be a positive x to the fourth, negative x squared, positive 1. You don't have to show that work, but if you needed to see it, there it was. So once we know what r squared is, let's find the domain for this, the upper and lower limits of integration. And it looks like we're going from 0 to 1. So what is the volume of this? The volume every time is pi times the integral of x squared dx, and we're going from x equals a to x equals b. I'm emphasizing this x business because sometimes this is with respect to y, and then it's y values. The specific problem, we are integrating from 0 to 1, x to the fourth minus 2x squared plus 1. Now, if you use your calculator like it's asking you to, we can just leave this pi chill here, and we can say the volume is going to be, I got 8/15 pi, or perhaps you got 0.533 pi. I'm going to leave it as 8/15. And this is cubic units. Just a refresher, how do you find this in your calculator? Well, you put this into y1, graph it, make sure your x window goes at least 0 to 1, Then you do second, calculate, integrate, lower bound 0, upper bound 1, and you're going to get this, or 8/15. See, even if you can use your calculator on this, the concept is the part you got to understand. Executing it without a calculator is not much more work than executing it with it. Let's check out number 3. Revolving about the line x equals 1. All right, so this is our revolution. We got the line x equals y minus y, x equals 2 minus y squared. So that is this curve here. We got x equals 1. So we're going to take this right here and revolve it around. If we do that, we're going to end up with this in a 2D space. It looks like that. In a 3D space, we've got a bunch of circles in here. Now this problem is a lot different than the other one. When I say a lot, I don't actually mean a lot, because our equations are written with respect to y. Our radius in each of these cases is going to be the distance from 1 to this y to this curve, which is in terms of y. So step 1, draw the picture. Let's label this stuff. Step 2, what is r of y in an effort to figure out what r squared is. R of y is the distance between these two. It's the absolute value. So I'd always if you just go from the right to left or top to bottom, big minus small, upper minus lower. Upper in this case is to the right. So we got 2 minus y squared, and we subtract from that this value here, which is 1. And then this is going to simplify to 1 minus y squared. I'm sorry, that's not right. It does simplify to 1 minus y squared, but that's not what r squared is. R squared is the square of that, which is going to be 1 squared minus 2y squared plus y to the 4th. If you want to write your terms descending order, then you could rearrange those. Step 3, what's the upper and lower bound? Well, the upper and lower bound from this, we're going to go from -1 to 1. We can call that domain if we want. So we're used to saying domain is the x values. It's not really true. Domain is what you're putting into the function. And in this case, I'm using the word function loosely, it's what you're let's not use the term domain. I'll tell you what, I used domain for all the homework. I'll just leave it like that, even though it's a little bit icky. 4, what's the volume? The volume is going to be pi integrating from y equals a to y equals b. Why? Because r is in terms of y. So this volume is going to be pi integrating from -1 to 1. You got 1 minus 2y squared plus y to the 4th with respect to y. This is clearly a calculator problem. You're going to end up with this being 16/15 pi or 1.067 pi. So depending on which version of that you have, you write your answer here. And we are in cubic units because it's volume. We got one more. It would be wise if you were to stop this video, do this problem on your own, and then check out how I did it. And we're back. Number 4. X equals 2 minus y squared. That's clearly this fella right here. And then we have x equals 2, x equals -2. That's telling us what our boundaries are. So that means that we are taking this weird shape here and revolving it about x equals -2. And if you look here, that's 1, 2, 3, 4 units. So it's going to be 1, 2, 3, 4 units. So it's going to look something like this. And we're going to have these circles coming around here. In each of these cases, an infinite number of those. 2, what is r of y? Well, r is the distance from -2 to 2 minus y squared. And we usually go big minus small because we want this to be positive. So that's going to be 2 minus a -2 is 4, so it's going to be 4 minus y squared. That's going to make r squared of y 16 minus 8y squared plus y to the 4th. And then what's our upper and lower bounds for this? Well, we're going from -2 to 2. These have to be y values because the function is in terms of y. So then we find the volume. Volume is pi integrating. In this case, it's r squared of y with respect to y. So we're going from y equals the lower bound to y equals the upper bound. So in this case, we got pi integrating from -2 to 2. We said that r squared was 16 minus 8y squared plus y to the 4th. Mad props to y. Put this in your calculator, and you will get 34.133 pi. Once again, I don't put the pi in my calculator. I just do this part and then multiply it by pi. And this is cubic units because we are finding a volume. Well, that concludes the notes. Hopefully you enjoyed that as much as I did. I think this is super cool, much like myself.